In this video, we will be talking about voice onset time, a phonological feature specific to stop consonants. A stop is a plosive consonant in which airflow in the vocal tract is fully occluded for a brief period of time, requiring complete articulatory closure in the oral cavity. The English stop consonants are as follows:
P, B, T, D, K, and G.
These syllable initial stop sounds are differentiated primarily by two things: the point of articulation, also known as place, and voice onset time, also known as voicing. Stop consonants occur when intraoral pressure rises during a period of closure and drops upon release via the venting of air through the mouth, yielding a release burst. Differential voice onset time for such consonants is determined by the delay between the release of the burst of air and the onset of the vibration of the vocal folds.
Consonants that are unvoiced will have a positive voice onset time, categorized as long lag, where voicing begins well after the stop release. Examples of unvoiced consonants are p, t, and k. Consonants that are voiced, also referred to as resonant, will have an onset time that is positive or zero. Examples of these would be b, d, and g. These will be categorized as voicing led if voicing begins before the stop release, or short lag if voicing begins during or shortly after stop release.
Voiced, voiceless unaspirated, and voiceless aspirated plosives all have different voice onset times, even though they are all bilabial plosives. In a voiced consonant, for example, vocal fold vibration begins when the lip closure is still occurring.
An example of this would be when a person says b as in ball.
In a voiceless unaspirated plosive, vocal fold vibration begins with the release of the lip closure.
An example of this would be when a person says p as in pan.
In a voiceless aspirated plosive, voicing begins even later following the release.
An example of this is when a person says p as in push.
Here, the difference between a voiced B above and an unvoiced P below is shown. The later voice onset time in P is seen as compared to the onset time in B, represented by the fact the vocal fold vibration for P begins later than it does for B. To demonstrate this concept in the words ball, pan, and push that Haley stated before, here's what the spectrograms would look like on Pratt. As you can see, pulses are visible during the onset of the plosive B when ball is stated. Vibration begins right away, and so voicing starts.
Ball.
For P in pan, vibration begins at a later time, and the pulses represent this, as there is a gap before the voicing begins.
Pan.
For F in push, vibration begins even later, and it is clear through the spectrogram that there is a large space at the beginning, and pulsing begins even later.
Push.
The difference in voicing between ba and pa is shown here in a different way. The dashed line in the pa graph shows the lack of vocal fold vibration, while the thick blue line indicates the vocal pulses are occurring. When comparing the length of time elapsed on the x-axis between the thick line in ba and the dashed line in pa, the difference in the start time of vocal fold vibration between the stops p and ba is the voice onset time delay.
Continuing to look at the differences between pa and ba, it is seen here how voice onset time affects the differential perception of the two consonants. At a certain point, a phonetic boundary occurs, and the voice onset time becomes delayed enough that listeners stop perceiving the phoneme b and begin perceiving the phoneme p.
Here, the difference in voicing is shown on a wideband Spectrogram. As you can see on the spectrogram on the left, the vocal fold vibration starts almost immediately for the sound ba. On the right, for pa, the white space seen at the beginning of the spectrogram shows a lack of vocal fold vibration. Voice onset time is an integral part of speech that influences our perception of a word's meaning. The delayed onset for the p sound, for example, is what allows us to perceive pest as a different word from best. Contrastingly, the immediate voice onset of duh causes us to perceive do differently from the word to. Differences in voice onset time allow us to distinguish between the different words in the English language. Therefore, training in perceiving and producing different voice onset times could be a key element in accent modification and voice disorder therapy.